We're coming up now on a year since Andreessen Horowitz and Iconic Growth dropped $100 million on Pinecone, the market leader in vector databases, which are the building blocks for large language models like GPT. At this time last year, Pinecone had about 1,600 paid customers, including Shopify, Zapier, and Gong. Here's one of the news stories that came out about that. And based on their reported growth rate in Q1 last year, Pinecone might well have tens of thousands of paid customers by today. Here's why. Once you start planning a generative AI project, you'll need a vector database, or at least some kind of vector alternative as the memory layer for that. And since Pinecone was an early mover that helped to create the category, you'll probably hear about them. And maybe you'll ask yourself, what is Pinecone? In fact, that might be how you got here. Okay, let's answer that. Pinecone is an external vector database where we can store contextual data for our language model. So we don't have to send big collections of documents back and forth every time we do an API call. We can just store them in a database and then use only what's needed each time. And the reason we need our data in the form of a vector is that transformers are now the dominant type of model that powers generative AI. For example, GPT-4 is a transformer model. In fact, that's what the T stands for. GPT stands for Generative Pre-trained Transformer. So, before there were transformers, models had processed information sequentially, but transformers consider all parts of the input text at the same time. That approach was introduced in the famous paper, Attention is All You Need, which is now a classic in AI literature. And, as described in that article, a key role in the process is played by something called text embeddings, which are basically mathematical representations of words, where similar words are represented in a similar way. The same embedding model is used to encode the original content and also the queries that are entered by our users, so the appropriate links can be made between the two. And in these transformers, the text embeddings are always in the form of a vector, which is a one-dimensional array of numbers, where each number represents a feature or attribute of the text or other data. And that is very different from a relational database that's structured in columns and rows. In a traditional database, we're probably looking for an exact match to our query. But in a vector database, we're only looking to find a result that's most similar to our question, which is done using measures like cosine similarity, for example, or other options. So, we need continuous access to those vectors. Now, let's say I'm using OpenAI on Microsoft Azure, for example. Is there a turnkey vector database over there that's already set up to handle all this for me? No, there is not. Instead, Azure offers third-party solutions like Pinecone, for example. Or there are open-source vector databases like Weaviate on Kubernetes. By the way, this video isn't intended to be only about Pinecone. It's really about the category. And there are many competitors now because it's a big deal. Companies like Quadrant, Vespa, Milvus, Weaviate. Here's a list of 15 options for that with pretty good descriptions for each one. But you can see also that Pinecone is pretty hard to overlook there in first position. I'll leave a link to this page for you in the comments. By the way, do we have to use a vector database? Are there no other options? There are options. One option is to use standalone vector indices like FAISS, which stands for Facebook AI Similarity Search, which is a library that allows us to compare vectors, with very high efficiency, by the way. Here's a video where James Briggs walks through how that works. I'll leave a link to that for you in the comments as well. But that having been said, vector databases definitely offer advantages over the standalone option. Those advantages include an easier process to update data, including real-time updates, better access to metadata, more efficient backup, easier handling of embeddings, which results in lower latency. Plus, there are built-in data security features and access controls. Also, databases are easier to scale, and they can be more robust. And for an enterprise, a big consideration is a reliable back end, because there'll certainly be performance targets and SLAs. And that is one of the reasons that Andreessen gave for investing in Pinecone. By the way, let's not imply that it's either or, indexing versus databases. Vector databases use indexing too. They do that to enable faster searching. Also, vector databases can usually integrate better with other parts of the tech stack, for example, your ETL pipelines. And there'll be APIs that can link to other applications like OpenAI and LangChain and quite a few others. And the result is that some AI tasks can be modeled directly as vector search problems and run right on the vector database without a final model inference step. Examples of tasks like that include product recommendations or ranking for a feed. Lastly, let's not forget to mention serverless architecture. You see, what we talked about until now gets us to something that's accurate and fast and scalable, but also fairly expensive. On the other hand, the serverless option opens the door to strategies that reduce cost in various ways by gaining different kinds of efficiencies. So the cost for serverless will end up being many times lower. And to close this out, here's a list of some of the AI applications that can be enabled using vector databases like Pinecone. Okay then, I hope that was a good answer for what is Pinecone. Thanks for watching, and see you next time.